Welcome again. And with this topic, I would like to talk a little bit about Isobus and in agricultural or Isobus. And you can also say this is kind of J1939 in agriculture and forestry machinery. This is why, it fits perfectly to this topic of this technology day today. And so for those of you who haven't not heard about this, my presentation is structured on motivation, what is behind Isobus. Then I would like to give you a little bit insight to the Isobus, and then conclusion and outlook, because here, as always, we are in the middle of new innovations, and such a standard is a living standard, and it is never finished. So what is Isobus about? If we talk about Isobus in agricultural world, then a typical equipment is a tractor, and a tractor is well standardized, or it has been standardized. And so most of the interfaces are mechanical interfaces, so therefore we have the 3-point hitch, we have hydraulic valves, and we have the PDO here. And this is used or has been used for a very, very long time. And it is very well specified, and you cannot imagine any tractor or any agricultural component which does not support all, or at least some of those interfaces. And so the question here is really what is missing. And as Holger mentioned, for a very long time, the exchange of data is missing. And so therefore, beside all these mechanical interfaces, the Isobus is really a way where you can attach a implement to a tractor, and you have a additional control channel beside the RPMs of the PDO or the hydraulic valve. You can really establish a data communication to your interface and perform additional actions and tasks. And to do this in a standardized way, you can simply say, adding Isobus to an agricultural world simply allows you to do the following. So you have a tractor, you have an implement, and in the past, it is very likely that this implement only works with this specific tractor, because every implement in the past utilizes its own electronic control units, and they had to wire a individual separate component in the cabin of the driver here. And if you attach this implement to a different tractor, then you would have to do the wiring again. And so there is not really a good or great interoperability. And Isobus tries to overcome this limitation, and then by means of Isobus and these mechanical interfaces, this is possible. And the good news is, since a couple years, this is already reality. So Isobus is in the field. It is really widely spread around, and you can, meanwhile, connect any type of implement to any tractor, and you can, beside the mechanical interfaces, you can control from inside the tractor certain features with a CAN-based data link directly from the cabin. And so this is really the most significant improvement since years to the agricultural world. And again, Isobus is a way to do this in a standardized way. It is no longer a proprietary thing or a manufacturer-specific thing, so that only whatever a green tractor only works with green implements, because they seamless fit together in all aspects. Here it is really so that a class tractor can utilize a Fendt implement, or a John Deere tractor can utilize a class implement, and so on, or Krone and Krimme. All those different manufacturers work hand in hand together, and the farmer can simply connect those by plug and play. So this is the motivation for Isobus, or has been the major motivation. And so the question here, beside the technical ones, you have heard about J1939 in general. This is, of course, the technical base behind all this communication. And so I would like to focus here a little bit on if you are new to Isobus, or if you consider Isobus for your own product development, then for you it's probably of interest who is behind Isobus. Yeah. And so therefore I have tried to lay this a little bit out here. And over the time, we have had several different organizations, but this picture here is stable for a couple of years now, and it looks like it will be stable for the next whatever years. So this is the current situation. So AEF, the Agricultural Industry Electronics Foundation, is an organization which owns the term Isobus. And so this organization is owned by the industry, by the member companies. Everybody can join this organization. There is, of course, a membership fee. And then once you are a member, you can work on the technical standards. And the advantage here is that everybody can contribute to AEF. So it is mainly the industry, and it is mainly international. If you look at the beginning of Isobus and the standardization activities, it has been mainly the North US or Europe, but by founding the AEF, the complete industry worldwide can be now participate and work without hurdles inside this organization on the standards. Especially in the USA, there are already existing organizations like the AEM, and they collect all those US activities and speak with one speech into the AEF. And then inside Europe, we have the VDMA, which is a very large organization. And by the way, the VDMA is the ISO secretary for the standard, the ISO 11783. And there is another organization, the CCI, the Competence Center Isobus, which also is a member of the AEF. And the CCI usually reflects or is speaking on behalf of many of those very small manufacturers. So if you have only a few implements, then it might not be worth, or it might not be feasible for you to work directly inside the AEF. Then you may decide to go to the CCI and become a member here. And then you can, together with the other small manufacturers, you can sum up everything here, and then it can be forwarded, transferred to the AEF. And it might be that you have a higher weight in comparison if you would be here on your own. So the CCI, the Competence Center Isobus, is an organization that is working within the AEF, but it does a lot more. So the CCI, for example, creates common software components, and this will be shared between the members, so that not everybody has to do practically the development of certain software components. So this is really an organization that has a little bit of broader scope than just defining the Isobus. And then, of course, the VDMA, this is the major organization here. It is the secretary, or holds the secretary of the ISO 11783, and is very tight with the AEF, because the AEF creates all those documents, and therefore they run several project teams with different tasks. And once they have created a new version of the standard or whatever, then they implement prototypes. They really test this together with the industry. And if it is somehow mature and it really fits the requirements of the industry, then the AEF together with the VDMA manages that those amendments or new versions of the standard make its way into the ISO organization, and then it will be processed by the ISO rules, so that at the end of the day, the work of the AEF will be reflected one by one in the ISO document and become an international standard. And since we all know that doing standardization is an ongoing work, dealing with practical implementation issue is probably something you need to solve today. Working on an ISO standard is probably something that takes at least a couple of years, because it is not so easy possible to update a standard. You have to follow certain rules. A standard in general lives for about 5 years. Then you can do a major review. In between, you can provide amendments. But this is also always a problem if you have issues in the field with the standard and you need clarification. And therefore, AEF is really a benefit for the whole process, because practically the AEF is the one that does the standard, and AEF also is the organization that provides a conformance test. I will come later back to the conformance test, because if you consider doing anything for Isobus, then practically you have to do the conformance test. It's not mandatory by law or something, but in the market, the quality claim of the conformance test performed by AEF or test institutes enabled by AEF is somehow mandatory, because yeah, you will learn about this in a few slides. So this is how the world plays or works together in the Isobus environment. And regardless if you are organized in one of those yeah, sub-organizations, or if you are directly related to the AEF, if you consider doing Isobus developments, it is not enough to simply buy ISO standards and implement ISO standards. I really tell you, you need to go to the AEF, read their amendments, read their documents. If there are uncertainties here, they will provide you with information which clarifies this. In between, it is officially handled in the ISO document. So if you do development, you should really consider talking to the AEF and get their document versions, amendments, and so on. And if you need to yeah, impact the standard, you can wait until it is processed in the ISO. But I would urge you to do this ahead and directly try to do this inside the AEF, because that will yeah, give you a better idea about the other stakeholders, and the acceptance is probably higher here in this consortium than if you come very late at the point in time when everything is done here and is simply handed over to ISO to become an international standard. Of course, formally everything is open. ISO is independent from the AEF, but yeah, practically you should really try to address issues within the AEF as early as possible. The Isobus compliance, this is what I mentioned earlier a little bit. The real world is really like we have the ISO standard. Officially, if you buy the documents, this is the major part. And then you have all these amendments here, this blue circle, coming from AEF, and they provide this by means of guidelines in an early version. And if the ISO standard is already published and there are issues in the field, then all these differences and interpretation clarifications will be handled in guidelines. And so again, the Isobus compliance later on is somehow in between the standard and the guidelines. So the summary is the Isobus and the Isobus compliance, and this is really what you should take into consideration if you plan to become active in the Isobus environment. Simply buying the standard, again, I can't tell this often enough, is not enough practically to provide devices for the market, because you may suffer on compliance, and you need to take into consideration a implement and a tractor the first time they ever meet is on the field, and the integrator that puts both systems together, the tractor and the implement, is the farmer. And it is truly and deeply a plug and play system. If it works, it's good. If it does not work, the farmer has a problem, and this is bad for the farmer as well, for the tractor manufacturer or the implement manufacturer, because it always causes a lot of trouble. And so therefore, compliance and plug and play is really a high goal that needs to be achieved in comparison to, for example, a J1939 component, which typically is integrated by people that know about the application, that know about the physical layer, that know about how to overcome issues and how to address issues. A usual farmer is probably not able to do anything else than plugging together a socket and a connector. And if it works, great. If not, he has to call a service technician, and this costs money, and this delays the harvesting process and so on. And so therefore, compliance in this market is really everything. And if you fail to deliver devices, then you may have a bad reputation in this market. And because of this compliance and the high value of compliance, the AEF has a huge database. And practically, if you buy equipment, your dealer will not sell any equipment to you as a farmer if he does not check by means of the AEF Isobus database which device has passed the conformance test, which device is offering which functionality, and by means of those classifications here, we will learn about later what a universal terminal, a tractor ECU, and so on is. So all those blue boxes here, they represent a certain functionality with a certain version number. And if those match together, then it is ensured by means of the compliance test that those two devices will work together in the market seamlessly. And then it's pretty easy. You can take them, and it is not really guaranteed, but all of those devices have been tested, and there's an extremely high chance that they work in the field if you connect them as a farmer. And so we have all those products listed, and if you would really seriously supply material to the agricultural world and you are not listed in this database, then you are probably not visible at the marketplace where the decision makers meet each other, because you won't spend a lot of money without getting the guarantee that it works with your tractor. So therefore, it is not mandatory, as I mentioned, but practically, if you provide components without a compliance test, you will never be listed in this database here, and then you will have a hard time to become visible in the market. And then, so you have the products, then in this database, you have the functionality and the version. And then that would lead to a certification statement here. Everything is certified. And then you can simply pick those components as a farmer, and then it works. So this is why I mentioned this. In comparison to J1939, there is no compliance, no official compliance. You have compliance documents, but everything you do it by your own, and you probably have to work with your components together with the integrator, with the OEM or whatever, and integrate your system. Here it is the farmer, and you cannot really travel to each farmer and integrate your whatever sprayer to each tractor, so that is not feasible. So the ISO documents, the official documents, are listed here in this sheet. So I have done this just for your information. If you look up the standard, you can download those file by file from the ISO server. I would recommend to you really to buy them all, because there are cross-references throughout those different standards. Certainly one of the important standards is 2 and 3, the physical layer as well as the data link layer. So if you are familiar with J1939, which I believe, then the 3 here is somehow comparable to the -21 or the -22, which I recently spoke. And the physical layer is similar to -17, 16, and so on. So ISO 11783 really has the technology base on J1939. So therefore, you will see a lot of similarities between Isobus and SAE J1939. So they share parameter groups, they share the transport protocols. However, we will see this later, Isobus is not J1939. There are some extensions, some exceptions, and you have to be aware. So you cannot develop a device that goes into the trucking world and exactly the same device will go in the agricultural world. You need to be aware about the differences. But in principle, yeah, it is extremely similar and it has definitely the same roots. And so as you can see, the standards are around here since several years, and I have published here for you a status information. For example, this one here, the general standard document is published in 2017, and it will go under the 5-year review in 22. Same is here for the network layer. And then here, this one shows there is a new project, the implement message. There's a new project registered. So this document already exists, but there is a new one coming. And the plan is that the international standard is published in 22. I say it is a plan. It may be delayed. You never know. But if you download today the -7, you may keep in your mind or in the back of your head that there is soon a new version coming. So therefore, be prepared if you start a development now. Here, you can expect a few changes. And so this one here, for example, the powertrain messages, there has been no changes. It is released and it is confirmed without changes in 21. The tractor ECU, which is a major part, is under review in 21. Here you can expect some changes. Task controller is confirmed as it is, or will be confirmed as it is. You never know. The process allows you that there's a late change, but this is the plan here. So don't take this literally. So this gives you an idea. If you have to deal with one of those documents and you look at this table, you probably can check, okay, is this a stable one, or do I have to take into consideration that there will be some changes. Again, if you are part of the AEF, then you are able to get access to the AEF documents, and then you can really learn what is the motivation, what are the changes that will be handed over to ISO, and you can discuss there with all the experts. And yeah, if you're really doing development, consider yourself to get yourself in touch with AEF, either by one of those surrounding organizations or directly working together with the AEF. Inside Isobus, not to be too abstract and tell you too much about what you should formally consider. What is Isobus about? It is as every CAN network. It's a simple bus, and you have certain ECUs connected to the bus. And I shouldn't say the new thing, but Isobus itself has a clear definition of this data link here, the blue one, including the connectors. So the IBBC, the breakaway connector, Isobus breakaway connector, that really allows you to set up the network between the implement and the tractor itself. So you have two of those breakaway connectors, one in the front, one in the back. And you can also daisy chain. So each implement can offer IBBC here on the back so that you can concatenate this train or agricultural train with multiple trailers or implements. So a implement can hook another implement as usual in the agricultural world. And so the Isobus is prepared to handle all this. One of the major components which I would like to speak a little bit about is the tractor ECU. The tractor ECU can be considered as the gateway between your private or proprietary network on the tractor and the Isobus. So for example, typically, not mandatory, but very typically is that the hitch and your hydraulic valves are controlled within your proprietary network. However, the implement is allowed to lower to control the hitch, to control the valves. And so the Isobus implements will do so by means of Isobus. And then there is a standardized interface to control these hitch position and the hydraulic or the hydraulic valve, so the PTO, the rotation speed of the PTO, by means of a public interface here on the tractor ECU. And then the tractor ECU typically controls those PTOs, hitch, hydraulic valves from within the proprietary network here. The same is true for transmission and brake. And the latest development on the tractor ECU is that the implement can take fully control of the tractor, including transmission, including brake, including steering. So a implement connected to a tractor, and if everything is set up appropriate, can really work as one integrated device, like a self-propelled harvester or something. So you can achieve this now with the latest development of the TECU features and any implement here. It is a complete extra story. I don't want to go too much into the detail. You may ask me in the Q&A session a little bit about this. Of course, it is embedded in a safety and security strategy. It is not that a simple CAN frame can start or stop the tractor or can steer the tractor. It's not that easy. But from the functionality point of view, Isobus is really high sophisticated, and it allows really the implement to do anything and control anything on the tractor. So the TECU is one of the key components. And then from a more visible point of view from the tractor, from the farmer perspective, is certainly the UT, the universal terminal. Sometimes you hear about the term virtual terminal. So you can consider the universal terminal as a browser. So a implement can upload images and control images to the universal terminal, and then probably by means of a touch screen or physical keys, the farmer can operate all these functions from inside the cabin by means of the universal terminal on the implement here. So if this is a loader wagon or whatever, you can lift this wagon, or you can steer. If this is a sprayer, you can control the amount of the fertilizing stuff or whatever directly from inside the tractor cabin, utilizing a single universal terminal. And regardless which implement you connect to the tractor, each implement will upload its individual object pool, and the object pool will be displayed. And again, as I mentioned, it is similar like a web browser. So this is the web page, and this is your browser. You view the web page, and then you can, by pressing buttons and so on, you can simply control everything here. So this really reduces the need or eliminates the need that you do extra wiring between the tractor and the implement, because everything can be done by means of the universal terminal and the existing Isobus. So the farmer can control everything here. So this is probably the most visible device that a farmer experiences if it has Isobus support, because the universal terminal is the central feature that you use every day. It's needless to say, there is also a joystick which comes as an auxiliary device that can support the touch screen or whatever keys. And this can be configured by the farmer. This can and assigned to certain functionalities on the implement, on the back as well as on the front. So it is really high sophisticated, and you have also headland steering units, so that the tractor can automatically perform certain actions, lift the hitch, make a turn, lower the hitch, and then go ahead. All this can be done with automated procedures, and they can be taught in. And yeah, it's really, yeah, I shouldn't say unlimited, but everything that is state of the art can be achieved by means of Isobus. And everything is split up in different features, different functionalities, and can be on an optional base attached to the network, so that you have really an Isobus which is scalable from entry-level tractors to the high-end tractors. So if you have those tractors that are utilized from yeah, family owners. So especially in the south of Germany, you have a lot of family-owned farms, small tractor, less people, and they need they have these less equipped farming equipments. And then if you go to the northern part of Germany, you have typically large farms because you have so much space, and there you have yeah, you have organizations that perform a lot of your farming jobs for you. And so you can simply book them and say, okay, do the harvest for me, do the spraying, do the fertilizing for me, and they will do this, and you have to pay for, and you have to assign them several tasks, and then they will perform those tasks. And to support this also, we have task controller here, where you can download as a farmer from your farming PC directly to the task controller a certain task, and then your service provider can perform this task on your field, and also can record exactly to document what he has done. And then after this has been done, the task controller will upload the finished task to the farmer PC, and then the farmer knows, okay, this job is done, and next thing comes, and so on. So there's a lot of high sophisticated features, and everything today goes through a single CAN bus using the communication principles of J1939. And the big difference, of course, are the parameter groups, the application layer. So there is less or no similarity content-wise to the truck and bus applications. Yeah, this is the Isobus topology and typical components that you will experience on an Isobus. And I have talked a lot about the tractor now, and here on the implement, you typically have the implement ECU. Sometimes it's called the chop ECU. So this is typically the control unit that does everything here on the implement, and it is simplified here. In a real world, most likely the implement is somehow a gateway from the Isobus to your internal network here. So you are free what you need to do on the implement bus. However, your public interface to the Isobus, this is what is considered to be the implement ECU. So the Isobus communicates through this implement ECU to your local connection, to your local network, whatever you have here. Most likely on a very simple implement on a plow or something, you will only have one ECU, and that does everything. But on a sprayer with whatever 100 of nozzles, you have additional electronic equipment, and then you need to define up to which level the Isobus really goes through, or if you block them on a one gateway, and then you do your own proprietary steering. But the commands and the control features will be communicated by means of this implement here. The Isobus is not J1939. I have mentioned this a couple of times. Now I will tell you a few things that are definitely different. So on the application layer, as I mentioned, on Isobus, you have additional DDIs. So this is a data dictionary identifier. This is more or less what you consider a SPN in in J1939. However, it is the transmission of the DDI is usually done DDI by DDI. So one signal, one SPN per parameter group. But therefore you have a lot of those DDIs, and those DDIs typically control the complete implement. So this is a approach that you do not utilize here in J1939. So here you have a fixed mapping of your suspect parameter groups of the SPNs to parameter groups. Here it's very likely that you have only a way to transmit such a suspect parameter group, but you only transmit those DDIs which has been changed or which needs to be communicated. So there's kind of a mapping. And another entity that you usually do not have on J1939 object pools. And the object pool is what I mentioned is, for example, the graphical description of what the universal terminal will show to the farmer. So this is handled by means of object pools. They have all those different information, and this is similar to the task controller describing a certain task and so on. Then you have dynamic network management. So the feature as it is also described and defined in the J1939 document. Most likely, I would say in best case, people consider this as optional. Practically, this is only an experience. It is not used. In Isobus, it is mandatory. And again, we have plug and play capability. There is no way around. If you do Isobus, you need to support the complete dynamic network management in any case. There's no way around. If you really consider skipping this, then you will fail sooner than later. Fast packet transport protocol is a extension to the BAM transport protocol. It is also available from the NMEA 2000, and it is used for GPS communication. Another extension to transport protocol is an extension to RTS-CTS, and this is typically used for uploading the object pools to the universal terminal, or if you have utilize a file server and you have to transmit a logging file or whatever, then you use more than 1,758 bytes, and then you use this extended transport protocol, which is not available at all in J1939. The DM1 transmission, the behavior is strictly here on change. In J1939, it is cyclic and on change. And so there is definitely a mismatch in the standards. Acknowledge parameter group, it is a extended address information available that tells the receiver which device sends the acknowledge. And this is meanwhile part of the SAE J1939 standard, so they have harmonized this, but practically there's only a week or no usage in Isobus. This is absolutely mandatory. The physical layer and connectors, there we have differences, so you won't attach a SAE J1939 connector to the Isobus and vice versa. Isobus also comes along with some degree of power supply for each ECU. It's not just the pure CAN network. And then again, this is what I stressed earlier a little bit, conformance test, practically mandatory, AEF tool available. So everything is in place. The only thing that is left over to you is you have to pass it, and this is hard. And the J1939 has only a test plan, which is described, and you can do and you should do, but nobody is really checking it. Here, it is a third-party organization that tests it, and if you pass, you will get into the database. If not, you will be out. Conclusion, outlook. I guess I have 1 minute or so. Summary, if you would like to engage yourself to Isobus, then you can do so in multiple organizations. You can consider AEF or the surrounding ones if you have changes or if you really have questions. Isobus is already high accepted in the industry as well as the user. So Isobus is the standard for this information interchange in tractors and implement world. And any other proprietary standard has a hard time. And also on the tractor implementers or tractor OEMs, even if they have proprietary communication, they do this by means of Isobus. So there is, like with J1939, you can establish proprietary communication, but it is done by means of Isobus and within the rules of Isobus. AEF is continuously working on improvements, and so it is not a standard that is mature in terms of there will be no change. Of course, every improvement is backward compatible, but it is every aspect of the standard is under constant improvement, constant review, and because it is really a very active and very good maintained and accepted standard. So therefore, it is nothing that is somehow frozen. Outlook. Despite the activities in the SAE with J1939 FD, which I mentioned earlier in my previous presentation, agriculture world is clearly heading towards a different way. So they definitely skipped CAN FD. So there is no chance for CAN FD and no chance for CAN XL. So they decided to go directly to Ethernet. So the next generation of Isobus will be based on automotive Ethernet 1000-based T1 and will come with all those fancy features with real-time communication and so on. So this is not published yet. AEF is working on this. It is nothing that you should supposed to come, or it's nothing that is supposed to come in the next year, but the direction is pretty clear. And so there has been already done a lot of work. And so, don't expect that your FD developments doing for J1939 can also be used in agricultural world. This, according to what is currently discussed, this will never happen. And I mentioned it earlier, the latest and greatest feature is a tractor implement management, TIM. And this allows a implement to fully control the tractor on any level, so that you can achieve any level of automation. And this really comes along with all those new world features like functional safety, security. You have to deal with encryption, with signed messages and so on to get access to this functionality because it's highly safety critical. So this is really, everything that is state of the art today is really packed into those tractor implement management functionality. This is very exciting. And it has already been implemented within the AEF, and this is really prepared to be submitted to the ISO to become a standard. But this is one of the great examples that the AEF did a lot of front work and implemented everything, double checked it. And now that it is somehow mature and proven, it is submitted to the ISO, and hopefully it will make its way through the ISO committee and will become a ISO standard so that it can be used under Isobus very soon. Thank you very much. This was really a very quick walkthrough. Hopefully this is information that helps you. And